Today's lesson, we're going to be learning about surface area and volume of pyramids and cones. Right now, I want you to go ahead and write down the definition of the pyramid, definition of height of the pyramid, and then slant height. So go ahead and pause the video so that the students can write down those definitions. So let's go ahead and read through the definitions now that you've written them down. A pyramid is a polyhedron. Remember, polyhedron just means a 3D shape made of polygons in which one face, the base, so we have a base, can be anything, and the other faces are triangles that meet at the vertex. So let's go ahead and picture this. I'm going to draw a pyramid. I'm going to draw right now a square pyramid. We have a base, that's a square, it's any shape. And all of our sides are triangles. So I'm going to connect all sides. They meet at the vertex. So all of the sides are going to connect to one point. So I picked a point, and all the sides connect to that point. Now the height of the pyramid is the perpendicular segment from the vertex to the base. I'm going to do this in green. We're going to go from the vertex to the base, and it's perpendicular, and this is my height. On pyramids and also on cones, we have this thing called the slant height. And the slant height is the height of one of the triangular sides. So here's a triangular side, and that is the height of it. And we use L for the slant height. For surface area, we're only going to be looking at surface area of pyramids. And here's our first example. We're going to continue using the definition that the surface area is the area of all of the faces, the sum of the area of all the faces. So let's think about what we have here. So let's draw out our pyramid. Go ahead and write down the example. And let's draw it out. We have a square pyramid, so draw your square base. And I like to just kind of make my vertex and connect all my corners to that vertex. So here's my square pyramid. The base edges are 5. And my slant height is 3. So that's this side. Now for surface area, we're going to find the area of all of our faces. Base number 1 is our base. Our base is what's our base? A square. That's 5 by 5. And then we have all of our sides. Now our lateral faces, by definition, lateral faces are triangles. Since we're a square, all the triangles are the same. So we're going to have plus 4 triangles. Let's look at the dimensions of the triangles. The base of the triangle is 5. My height of my triangle is 3. Because remember, slant height is the height of the lateral face. Let's find the area of each of these. Well, area of the square is 5 times 5, so that's 25. Here I have 4. Area of a triangle is 1/2. We have 2 perpendicular segments, so we have 5 times 3. So that's 15/2. Continue on. 25 plus 4 times 4/1. So 4 times 15 is 60. 60 divided by 2 is 30. So that's 55 meters surface area squared. Our next example, we're going to find the surface area of a square pyramid again. This time our base edges are 12 meters and our height is 8 meters. Now this height refers to the height of the pyramid. Let's go ahead and draw this out. We have our square base. And with the pyramid, they all meet at a point. Our base edges are 12. And this time our height, remember height of the pyramid is from vertex to base, is 8. So to find surface area, we're going to find the area of the base and the area of each of the triangles. And all the triangles are the same again because it's a square. Now this time though, notice we don't have our slant height. We don't have the height. We need the height of the triangle. So we're going to have to find that. And this is how we find that. To find it, we have to picture a right triangle formed by the regular height, the slant height, and that dimension. Now that piece is half of my side. So my side is 12. So this piece is going to be 6. So I'm going to pull this triangle out. And to find the slant height, we're going to use Pythagorean theorem. 6 squared is 36. 64. We get 10. And yes, this is a 6, 8, 10, a 3, 4, 5 triangle. So now we have what we need. So we have our square base, that's 12 by 12, plus our 4 lateral faces, our 4 triangles. The bottom dimension's 12, because we're looking at the full triangle. And then the height, we found that the height of the triangle is 10. Here I get 144. The area of this triangle, 1/2. 12 times 10, we need 2 perpendicular segments. It's going to give me 4 times 60. Remember, we have the 4 times the 60. (144 plus 240), 384 meters squared. Moving on to volume. Remember, we're not doing surface area of the cone. So, volume of a pyramid and cone, we have the same formula. Area of the base times the height divided by 3. Again, remembering capital B. Area of the base, H. height of pyramid/cone. Remember, for the pyramid and for a cone, we have the slant height. So this is not the slant height. So our first volume example, we're going to do with a cone. Let's go ahead and draw a cone. I'm going to draw a circle because the base of a cone is a circle. I'm then going to think about 2 points across from each other and draw slanted lines meeting straight down, diagonally. I'm going to give you this dimension is 10 meters, and this dimension is 13 meters. And our final answer we're going to leave in terms of pi. So first of all, we're finding volume. Volume of a cone is area of the base times the height divided by 3. Let's remember that capital B is the area of the base. What's our base? Our base is a circle, so we're going to need area of a circle is pi r squared. The height, this is the height of the cone. Now the height of the cone is this dimension right here, from the vertex perpendicular to the base. We do not have that dimension, so we are going to have to find that. We find the height by picturing this triangle. I'm going to pull the triangle off to the side so we can see it a little better. (13) H, right angle, and then this dimension is our radius. Use Pythagorean theorem to find the height. And you should get H equals 12. This is a 5, 12, 13 triangle. So we have our H. Now we need to find the area of our base. Again, it's the area of a circle, pi r squared. Pi, look, what's my radius? I have the diameter is 10. My radius is 5, so that is 25 pi. I can now find the volume. 25 pi times 12 divided by 3. 12 divided by 3 is 4. 4 times 25, that's 100 pi meters cubed. And we left it in terms of pi. For our last example, we're going to be finding the height. So we're going to be working backwards. So find the height of a square-based pyramid. Let's go ahead and draw our pyramid. Draw the point that all the corners are going to connect to. Our base edges are 21. The volume is 2,058 centimeters cubed. And we do not know the height. Go ahead and write down our volume formula. Area of the base times the height divided by 3. Well, we know the volume. Put that there. Capital B, area of the base. Our base is a square. And that area, let's see, 21 times 21 is 441. And our goal is to find the height. Let's plug everything in. Volume is 2058. Area of my base is 441 times the height divided by 3. 441 divided by 3, 147. And when I divide by 147, I get h equals 14. So our answer is 14 centimeters.